Good morning, children. Hope you all are fine and safe. So, this class we are going to see a new topic, and the topic of the lesson is atomic structure 1. Okay. So, today you will get the assignment, children. For that, you have to allot a separate notebook for chemistry. Okay. Long size unruled notebook you have to allowed. Separate notebook for physics, separate notebook for chemistry, and for biology also you have to maintain a separate notebook. Don't use the same notebook for all the three subjects. Okay, separate notebook you have to maintain. Write your class work neatly. Okay, children? Right. So, what is the topic of the lesson today? The topic is atomic structure 1. Okay. Every object in our surrounding is made of unique elements. There are nearly 118 elements have been identified worldwide so far. Out of these 118 elements, 92 elements occur in nature, and the remaining elements are synthesized in the laboratory. What is the meaning for synthesized? Synthesized is nothing but produced. Okay, produced in the laboratory. Some of the elements like iron, copper, gold, silver are naturally occur in nature. At the same time, some elements like neptunium, promethium, plutonium, technetium are synthesized in the laboratory. You know very well, matter is made of very small particle, that is minute particles called atoms, isn't it? Right. Atoms are the building blocks of matter, right? Atoms are the building blocks of matter. The word atom is derived from the Greek word atomos. Okay. The meaning for atomos is smallest divisible particle, whereas the meaning for atomos is smallest indivisible particle. So, in this lesson, we will see about atomic number, mass number, electronic configuration, followed by quantum numbers, okay, and famous principles like Hund's rule, Pauli exclusion principle, right? And then de Broglie relation. What is the difference between particle and wave? And some experiments based on this particle and wave nature. Finally, we will see about the electronic arrangement of atoms as well as electronic configuration of atoms. So, we are going to discuss all these concepts in this atomic structure lesson. Before we start this lesson, first of all, you should know some basic, that is fundamental terms you should know for this lesson. Okay, then only we can enter into the lesson. So, what are the fundamental things you have to learn? Let me see now. First one is about matter. What do you mean by matter? Yes, matter is anything which occupies space and has weight or called matter. Okay, what is matter? Anything which occupies space and has weight, that is called matter. Next, what is atom? Just now I told you, atom is the smallest, very smallest particle of an element that takes part in a chemical reaction. Okay, these atoms are the building blocks of matter. Got it? Right. Next one is element. Element is nothing but a pure substance that cannot be broken down by chemical methods into simpler substances. Okay. Element is made of only one kind of atom. Only one type of atom. Got it, children? Right. Next one is molecule. Group of atoms bonded together are called molecule. For example, water. Water is composed of hydrogen as well as oxygen atoms, isn't it? So, group of atoms bonded together, then we can say it is a molecule. molecule. Next one is compound. Compound is composed of two or more separate elements. Okay, what is compound? Compound is composed of two or more separate elements. First one is, for example, we can say water. Water is a compound. Why? Because it is composed of hydrogen element as well as oxygen element. And we can say sodium chloride is a compound because sodium chloride is composed of sodium element and chlorine element. Okay. So what is compound? Compound means the compound is composed of two or more separate elements. That is called compound. Next one is ions. Atoms or group of atoms, they have some charge. Okay. Positive charge or negative charge are called ions. Okay. Atoms or group of atoms having a charge, that is positive charge or negative charge, are called ions. These ions can be classified into cations and anions. What is the difference between cations and anions? If you take cations, cations are positively charged particle, whereas anions are negatively charged particle. Both cations and anions are ions only. Okay, they have different electrical charges and they get attracted to each other. Got it? Ions means what? Atoms or group of atoms having a charge are called ions. Next one is atomic number. What is meant by atomic number? Atomic number means the number of protons which is present in the nucleus of an atom are called atomic number. Got it, children? So this atomic number definition is very important for this atomic structure lesson. Okay. So what is meant by atomic number? The number of protons which are present in the nucleus of an atom are called atomic number. Next one is mass number. Mass number means the total number of protons and neutrons which are present in the nucleus of an atom. That is called mass number. Okay. What is mass number? The total number of protons and neutrons present in the nucleus of an atom are called mass number. Got it? Right. Next one is isotopes. Isotopes means isotopes of an element have same atomic number but different mass number. Okay. Elements which contain same atomic number but different mass number are called isotopes. I will give you some examples for isotopes in this lesson. Next one, nucleus. Nucleus is present at the center of the atom. Okay, that you know very well. Next, subatomic particles. Atom consists of three subatomic particles. The three subatomic particles are protons, electrons, and neutrons. Okay, each and every subatomic particle has some charge. For example, if you take proton, protons are positively charged particle. At the same time, if you take electrons, electrons are negatively charged particle. Then what about neutrons? Neutrons are neutral in nature, that is they have no charge. Okay, so these things are very important for this lesson. This one, what are many questions you will get for the test. This fundamental things you should know. Okay, let's shall we move to the topic? Right. First, we'll start with some sample problems. Okay, so look at the first sample problem. One tabular column is given. Okay, tabular column is given. Also, some species starting from A to E is given. A, B, C, D, E. Okay, species are given. Their proton value, neutrons value, as well as electrons value are given in this table. What you have to do now? You have to indicate, okay, from this table you have to indicate the pair of isotopes. Okay, that is the question. What is the question? From this table you have to indicate the pair of isotopes. So first of all, what you should know for this Okay. Now look at the species A, B, C, D, E is given, and proton value, neutron value, electron value is given. We have to identify which species contain same number of protons but different number of neutrons. Okay. Look at all this proton value as well as neutron value. See here. Species C contains 17 protons as well as species E contains 17 protons. So C and E contains same number of protons. At the same time, what you have to do next? You have to find out the number of neutrons. Okay. Check the neutron value for species C. The neutron value is 20, and for species E, the neutron value is 18. Okay. So species C and E contains same number of protons. Okay, that is the same atomic number but different number of neutrons, different mass number. So the species C and E represent the pair of isotopes. Got it, children? Species C and E represent the pair of isotopes. Okay, here the 17 number is given. No, this 17 represents chlorine element atomic number. Okay, atomic number of chlorine is 17. Right? Atomic number of chlorine is 17. So species C and E represent the chlorine element. Okay, so species C and E represent the chlorine element. These two are the isotopes of chlorine. Got it, children? So once again I repeat, from this table we have to indicate the pair of isotopes. Isotopes means element having same atomic number but different mass number. Atomic number is nothing but number of protons. So we have to identify the number of protons. C species as well as species E contains same number of protons. At the same time they contain different number of neutrons. So species C and E are the pair of isotopes. At the same time, the 17 is the atomic number of chlorine. So these two species are the isotopes of chlorine. This is a sample problem 1. I hope you have understood. Now let me move to the sample problem 2. Okay, here two nuclei are given, that is nuclei A and nuclei B. Okay, at the same time, protons, nuclei A, proton number as well as neutrons values are given. For B also, protons as well as neutrons value are given. So what you have to identify from this? From this, you have to identify, you have to indicate the mass number of A, at the same time mass number of E, and also you have to identify what is the relation between these two numbers, these two nuclei. Okay. are the pair of isotopes. Okay. At the same time, this 6 value is given. No, this number 6 is a carbon element atomic number. Atomic number of carbon element is 6. So these two are the isotopes of carbon element. First you have to find out the mass number. Okay, next you have to give the relationship. Mass number already we got it 12, 14. So these two are the isotopes because they contain same number of proton but different number of neutrons. At the same time, next relationship we have to find out. The relationship is number 6 is the carbon element atomic number. So these two nuclei are the isotopes of carbon element. Understood, children? Sample problem 2. Shall we move to the next one? Right. Next one, sample problem 3. Which two of the following nuclei are isotopes of each other? 4 nuclei are given. First, you should know about isotopes. Isotopes means what? Element having same atomic number but different mass number are called the isotopes. Here, look at the nuclei. Here, we have to find out the atomic number, same number of atomic number. Here, the lower figure is given as well as upper figure is given, isn't it? The lower figure indicates the atomic number, whereas upper figure indicates the mass number. Lower figure indicates the atomic number, whereas upper figure indicates the mass number. Now look at this one. This first species as well as last species contain the same atomic number. Next you have to find out the mass number. Check the mass number for the first species 231 and for last species 233. Okay. So these two are the isotopes. Got it, children? First isotopes means what? Element having same atomic number but different mass number. From these 4 species, first species, this species as well as last species contain same atomic number. Lower figure indicates the atomic number, upper figure indicates the mass number. So these two species contains same atomic number. At the same time, they contain different mass number. So these two are the isotopes. Okay. Next, look at the second species and third species. They contain different atomic number. At the same time, they contain same mass number. So these two are the isotopes of each other. First and last are the isotopes, but these the second and third are the isotopes of each other. Got it, children? So the answer is you have to write the first species and the last species. Next you have to write these two species and mention these are the isotopes of each other. That is the sample problem 3. Next we can move to isobars. This is also very important definition. Isobars. What is meant by isobars? Isobars means atoms of the different element with the same mass number but different atomic number. Okay, once again I repeat. Isobars means atoms of the different element with the same mass number but different atomic number. Look at the example. First example they have given argon element. A orbits it mentions argon element. Look at the atomic number. Atomic number is 18. At the same time mass number is 40. See the second element calcium. Ca is calcium element. For calcium atomic number is 20 whereas mass number is 40. Okay. So what is given for isobars? Atoms of the different element with the same mass number but different atomic number. Argon is a different element and calcium is a different element. Look at the atomic number. They have different atomic number. At the same time, if you look at the mass number of neutrons. Look at this example. Carbon element as well as nitrogen element is given. For carbon element, atomic number is 6 and mass number is 13. And for nitrogen element, atomic number is 7 whereas mass number is 14. Okay. So how will you find the neutron? To find out the neutron, we have to subtract the mass number from atomic number. Then only you will get the neutron value. So what is the mass number here? Mass number is 13. What is the atomic number here? 6. So if you subtract the mass number from atomic number, you will be getting 7. Okay. So next one. See the nitrogen element. Its mass number is 14 and its atomic number is 7. If you subtract the mass number from atomic number, you will be getting neutron value. So what is the value you will be getting? 14 minus 7? You will be getting 7. So same number of neutrons you got it, isn't it? So isotopes. Isotopes means atoms of different elements with the same number of neutrons. Okay. For all these, that is for isotopes as well as for isobars and isotopes, you should mention the example. Then only you will be getting full marks. Right, children? Good. Okay. Now we can move to some important formula based on Bohr's model of atom. Okay. So first we are going to see about 3 important formula. One is about Coulombic force. Coulombic force is also known as electrostatic force. Okay. Coulombic force is nothing but the amount of force. It is nothing but the amount of force. It actually between the relationship between, it shows the relationship between. Okay, now we can move to 3 important formulas based on Bohr's concept of atom. Okay, first one is about Coulombic force. So Coulombic force is also known as electrostatic force. Coulombic force, it is also known as electrostatic force. Okay, it is the amount of force which takes place between 2 stationary electrically charged particles. So that is called the Coulombic force. The formula for Coulombic force is F is equal to Q1 Q2 by R square. Okay, here F is nothing but the Coulombic force, whereas K is the Coulombic constant. Okay, whereas Q1 and Q2 are electrical charges and R represents the radius. Got it, children? Second one, centrifugal force. Centrifugal force is nothing but when a particle moves on a circular path. When a particle moves on a circular path, okay, here between the magnitude as well as its dimensions, as the force keeps the particle on a circular path but just points in the opposite direction. That is called the centrifugal force. Okay. Its formula is F is equal to mv square by R. Here F represents the force, m is the mass of an object, whereas v is the velocity and R is the radius. Next one is angular momentum. The quantity of rotation of a body which has the product of its moment of inertia and angular velocity is the angular momentum. Its formula is L is equal to mvr. Okay, where m is the mass of an object, v is the velocity and r is the radius. L represents the angular momentum. You will learn about these formulas in detail in your higher classes. Now you just learn about the formula only and the basic concept behind this formula, right? So next we can move to the electronic configuration, electronic arrangement of electrons based on Bohr's concept of atom, that is the present concept of atom. Okay, you know very well, matter is made up of tiny particles called atoms. According to Niels Bohr, an An atom is made up of three subatomic particles. What are the three subatomic particles? One is protons, second one is electrons, and third one is neutrons. Each and every subatomic particles has some charge. Okay. For example, if you take proton, protons have positive charge. Electrons have negative charge. Whereas if you take neutrons, neutrons have neutral charge, that is no charge. Okay. Due to the presence of positive protons and negative electrons, an atom on the whole is electrically neutral. Okay. Next one, the protons and neutrons are present at the center of a nucleus. Okay, center of the atom, that is called nucleus. In the nucleus, protons and neutrons are present. Due to the presence of protons, the nucleus is positively charged. This point also you have to remember. Next one is about electrons. Electrons revolve around the orbits in circular path. Okay, electrons revolve around the orbits in circular path, that is called energy levels or shells. These energy levels or shells can be represented either by number 1, 2, 3, 4 or by the letters K, L, M, N and so on. Okay. Each and every energy level has some fixed amount of energy. For example, if you take the K shell. K shell is very nearer to the nucleus. Look at the diagram. Look at the energy levels in an atom. Okay. The center part is called the nucleus. So in the nucleus, what is present? Protons and neutrons are present. Nucleus is positively charged. Why? Because protons and neutrons are present in the nucleus. Protons are positive charge. Neutrons have no charge. That is why nucleus is positively charged. Okay. So these are nothing but the orbits. Okay. Orbits, or otherwise we can say energy levels. Here the energy levels already I told you, it can be represented either by number 1, 2, 3, 4 or with the letters K, L, M, N, O. Okay. And I told you each and every energy level has some fixed, energy level has some energy. Okay. Each and every energy level has some fixed amount of energy. Each and every shell or otherwise level, both are same only, shell or energy level. They have some fixed amount of energy. If you take the first shell is K shell. Okay, this K shell is very nearer to the nucleus. So K shell has minimum energy. L shell is little bit farther from the nucleus. So it has little more energy. And of course, if you take the outermost shell is the N shell for this arrangement. So this N shell has maximum amount of energy, higher energy. Why? Because it is very far away from the nucleus. Okay. So this point also you should remember. Next one, there is no change in the energy level of an electron when it maintains in the same state. Okay. But the energy changes takes place only when the electrons jumps from one energy level to another energy level, that is from lower energy level to higher energy level. Okay. Here the electron gains energy when it jumps from lower to higher energy level. At the same time, the electrons loses energy when it comes down from higher level to lower level, right? Okay, I told you electrons are negatively charged particles, so it forms a cloud of negative charges outside the nucleus. Okay, in this cloud, the energy levels are, here in this electron cloud, the energy levels are counted from the center outwards. So this is the outwards. Energy levels can be counted from the center outwards. Okay, your first energy level is the This is the first energy level, that is K shell. Second energy level is L shell. Third energy level is M shell. And fourth energy level is N shell, like that. Okay. Just now I told you the shell which is nearer to the nucleus has minimum energy, and the shell which has farther from the nucleus has maximum amount of energy. We know very well a system is stable when it has minimum energy. Okay. So now we have to know how the electrons fills the various energy level. Okay. First of all, K shell has minimum energy, isn't it? So the electrons first of all fill the K shell. Next electron will fill the L shell, then M shell, N shell, like that it will fill. Here you should know about the what is electronic configuration of an atom, right? The arrangement of electrons in various shells of an atom of the element is called the electronic configuration of an atom. In order to write the electronic configuration, we should remember 2 points. One is we should know the number of electrons which is present in one atom of the element, and we should know the maximum number of electrons that can be accommodated in each energy level. Okay. The maximum number of electrons which can be accommodated in each energy level can be, it was given by Bohr and Bury. Okay. Here the maximum energy level, by using a formula we can calculate the maximum energy level. Okay. By using the formula 2n square. The maximum energy level can be counted by using the formula 2n square. Here n represents the number of energy level. Here for n we can take the value as 1, 2, 3, 4 and so on. Okay. Now look at this tabular column. Electron shell as well as its maximum capacity range is given. If you take the K shell it contains maximum 2 electrons only. That is first shell is K shell. Second L shell contains 8 electrons. M shell has maximum capacity of 18 electrons, and for N shell 32 electrons. By using this 2n square formula, we can get this maximum capacity. Now we can calculate. Okay. First one formula is 2n square. Now we are going to take the n value as 1. So 2 into, what is the n value? N value is 1. The whole square, that is equal to 2 into 1 into 1 is 1. So 2 electrons. Okay, you got 2 electrons for K shell. Next one, we can take n value as 2. So 2 into 2n square, isn't it? 2 the whole square, that is equal to 2 into 2 the whole square is 4. So 2 4s are 8. You got the 8 electrons, isn't it? Next one is for M shell 18 electrons. So we can take n value as 3. So what is the formula we are going to apply? We are going to apply the 2n square formula. So 2 into n is 3 the whole square, that is equal to 2 into 3 3s are 9. So that is equal to 18 electrons for M shell, and last one is N shell. So here we are going to use the n value as 4 by using 2n square formula. 2 into 4 the whole square, that is equal to 2 into 4 4 you will be getting 16. So the answer is 32. Like this you have to calculate, children, then only you will get the maximum capacity. Okay. Here one point you have to remember, the outermost electrons cannot accommodate more than 8 electrons. What is the reason behind this? Keeping that is 8 electrons makes the atom very stable in nature. For example, if you take M shell and N shell, M shell has maximum capacity of 18 electrons and N shell has maximum capacity of 32 electrons. But you cannot accommodate 18 electrons, 32 electrons in the outermost shell. Why? Because if you give more electrons, then atom is not stable in nature. If you accommodate 8 electrons, then only the atom will be stable in nature. Okay. So we have to remember all these while writing the electronic configuration. Right, children? Okay, good. So next we can see, look at this one. This is the structure of atom. Okay, this is the structure of atom. Here, see, this is the center part is called the nucleus. The center part is called nucleus. So in the nucleus, what is present? Protons as well as neutrons are present. So this is proton and this is neutron. Okay, and here you can see what is this? It is nothing but electrons. Okay, electrons revolving around the orbits. Okay, electrons always revolve around the orbits, will spin with a very high speed. Okay, so already I told you each and every these are the subatomic particles. Protons, electrons present inside the nucleus, and electrons revolve around the nucleus. Okay, what I told you for protons, protons are positive charge. So protons are positive charge, neutrons are no charge, right? That is why nucleus are positively charged, right? And electrons are negatively charged particle. Okay, electrons are negatively charged particle, and this is the first shell, first energy level, second energy level, third energy level. Here it can be represented by the number 1, 2, 3, 4. Here it can be represented by the shell K, L, M and so on. Okay, so this is the first shell. So this K shell is very closer to the nucleus. So this K shell has minimum energy. At the same time, here in this atom, what 1, 2, 3, K, L, M. M shell is the outermost orbit, isn't it? This M shell has maximum energy, that is higher energy, because it is very far away from the nucleus. But K shell is very nearer to the nucleus. So K shell has minimum energy. Okay. So these points you have to remember well, children. And at the same time today you will get the assignment. You just allot separate notebook for physics, chemistry as well as biology. Use long size unruled notebook. Okay. Write the classwork neatly, question with the answer. Maintain the notebook. Separate notebooks only you have to maintain. Don't use the same notebook for physics, chemistry and biology. Right, children? So today what are the things we discussed? Everything you go through. Well, we will see the remaining portion in the next video. Thank you, children.